a video on progress, not in correct chronological order or an explanation that's true to life, but all over this world, various groups of people, without having contact with each other, and repeatedly throughout history, have discovered the following things. So we could decide that it was discovered in this order that I'm going to explain anyway. You find yourself being born somewhere on Earth. Doesn't matter where or when. You have no idea exactly where it is relative to any other place, but you are able to notice the following things. Mostly, depending on whether you're above or below the equator and whether you know it or not, the sun will appear to form an arc in the sky each day. And after a few years of being alive, long before you've decided to even pay attention to this, you will, on a visceral level, be aware of the fact that this changes in angle, and in fact the entire arc changes in angle. Almost like it's static, and its position in the sky for the whole curve that it does changes. This is one of the clues. And if you're in an area that has enough clear days and enough clear nights to do this, you can make note of it, and it'll become, on a visceral level, something you subconsciously and maybe consciously understand. Next, you observe the stars at night, presumably, and you'll notice that if you decide to stay up late enough, especially if you stay up an entire night, you'll notice the pattern that you see just before the sun comes up and the pattern that just before the sun goes down over, let's say, an entire summer or a winter, wherever you have the clearest skies to work with, you'll notice the patterns seem to wrap around. Eventually, you'll notice that at winter and summer, or during spring and fall at the solstices, or equinoxes, or whatever, some timings that are 6 months out of phase approximately, you will notice that you can almost draw a map. Now, all of these observations take years by their nature, but you can force yourself, if you want to be an astronomy major or an astrologer that actually looks at the stars rather than just looking at charts, that'll come up later, or a person who's desperately trying to navigate the sea or a mountain range or just the world itself on dry land, it's critically important for you to memorize these things. You know it is, because any place can have any pattern as you move over it, but the sky doesn't seem to change at all or much, except the passage of the moon, the passage of the sun, a few dots in the sky that are somehow bigger or blurrier but don't twinkle, that we now call planets, which means wanderer. And those dots wander the sky, the ones you can see. They become the basis, if you're not aware of it, for many of the several reasons that we have 7 days in a week. Over time, many generations, this information eventually gets collected, or you might experience a time period that's brilliant and wonderful where you're allowed to learn this at a four-year college. Most of the time spent above the cloud layer on a mountaintop, usually in wintertime because the winter nights are longer, freezing your ass off unless you got some hot cocoa and some reasonably good coats, observing the sky. It could be just an observatory where you're looking at things, or it might involve a telescope where you have to keep it ice cold or a specific temperature that's not very comfortable for humans. And this could have happened multiple times in history and could have been through multiple civilizations that we do and some we don't know about. Over this hard-won database, which has been destroyed multiple times, yes, I'm still angry about the Library of Alexandria, some people would have gotten together and realized, hey, maybe we should set this in stone somehow in some algorithmic or, Reader's Digest version. Like, there's a star in the north sky, we're going to call it arbitrarily the north, that as long as you're above the equator towards the North Pole, you can see what we're going to call the North Star, or Polaris. And in the southern sky, well, you can kind of approximate it with several different several different things that are a cluster and a space between them, or maybe just using the Southern Cross or something. And you find that if you use these as a reference point in some ways, you can get accuracy down to 10 nautical miles or less, even better. Now, how would you do this besides going from the equator to the North Pole? Well, this pattern that seems to flow over the Earth as a sphere that's contiguous, a wraparound effect, you can do a neat trick you find. Midday, noon, solar noon, You can look at the sky and figure out that the sun is at its zenith by doing one of two methods. One, just estimating it. Two, making very detailed notes by some method to figure out its exact position. Writing down as numbers or drawings, it doesn't matter. And you might do one where you see the disk of the sun pass an arbitrary point you've decided to call its zenith, and you measure the time it goes to here, and then the difference between being the exact point it's at the zenith. And it should be as high as possible. You can set up an observatory where you put your eye at a particular position and you can't move it, reference to some lines that you eventually end up having to draw across the opening, the aperture, looking up at the sky. And this makes it to where you can then, if you make a timing system like a clock, there have been many clocks, you can get to where you're plus or minus a couple of seconds for midnight, so you can do what is called solar midnight, which just seems like a contradiction in terms. And then you can look at the stars, if it's a clear sky, and you get lucky. And then you can map the stars that should be there from your reference point at midnight, so that when you're at another position and it's off by a certain amount, you can figure out how far around the Earth you've gone. Because by this point, you've realized if the sky wraps around the Earth, and we can see a specific portion of it, there must be another part of the world where they see a completely different sky. And when you do the experiment, because eventually people can travel, you do find that even over a distance of, let's say, in Europe, going to, let's say, India, on the day you're supposed to be able to look up at solar midnight and see this pattern, it's shifted enough that you can definitively see that it wraps around. That can't work if the Earth isn't round. You then proceed to learn more about the world, going north to south, the southern Horn of Africa, South Africa, all the way up to, let's say, Sweden, or that sort of thing. You see differences in the shape. That also means that it wraps all the way around north to south. And that's a very long distance from the Horn of Africa up, but it shows that it cannot be flat because it's curve-shaped in its behavior. But another thing you notice is that on those days you can measure those angles. And you notice the angles make it to where mostly the stars, not the planets necessarily, they're a bit too close apparently, and the sun and the moon are much, much closer than you would assume they would be compared to the stars. You notice by staring at these points that could be as far apart as 7,000 miles apart, that when you look at the stars, they do appear to be straight up. They have to be straight out there somewhere, a long distance, axiomatically. And at the equator, you can detect this angle that seems like they're completely parallel light coming from. It looks straight up, let's say, on that day. But when you go to the, let's say, at the spring or fall, not during winter or summer, at the equator, you see that they're straight up. But when you go here, they're at an angle. Now, either they're really, really close to the ground and over the equator, or the Earth is bent and it forces you to bend your lines up this way. So you test it at the 45-degree mark. The further apart you are on a round Earth, they just get like this. And then towards the equator it has to be the same line, because they're almost seemingly an infinite distance away. But if you do a flat Earth, they're pointing really close to the ground, and in the middle they're seemingly infinitely far away. And at 45 parallel, you get a different number entirely. If they're not consistent, it's not that the stars are bending around you to fool you. That's unnecessarily complex. You find that they are not really an infinite distance away, but very nearly, and the Earth must be curved. Same thing for sunlight, even though you can detect by doing this long-distance check that the sun is actually closer to the Earth from just the angles being slightly different, and the moon much, much closer. We also realize that since the Earth apparently is moving on its axis, rotating, and this field of stars is surrounding us, that's much less of a stretch. You consider the possibility that the Earth isn't having the sun rotate around it, because that seems a little excessive. Maybe the Earth is smaller, since you can estimate the distance from the sun, because you've been able to figure out the stars are so far away you consider them almost infinite. You can detect it has a specific size, and it's massive. The moon, much smaller. The moon clearly orbits the Earth. You can see it during day or night. So you try a little experiment. I wonder how far of a difference we will see if we're in winter or summer or spring and fall, equinoxes or whatever. I wonder if we look at the stars and see differences in them, because the stars can't all be the same distance. And then you notice, yes, there's differences with some of the stars. Many of them, in fact, are closer. But some of them are so far away they're effectively infinite. So you decide that you're going to have preferred stars that are visible at night easily, but are very far away, which means they're very, very bright, blindingly, if you were to be near them. And the closer ones are maybe even brighter, but they're not as bright as those. And you decide, that means that we have a universe with three-dimensional cloud of stars. And you start exploring this. And certain varieties of people go to great lengths to make sure you don't do this because it contradicts their simplistic teachings, enough so that they're willing to just burn you alive and call you a heretic. And how dare you build that Stonehenge? We will outlaw your belief systems by killing your children, or whatever we have to do, because we have power over other people by making sure they read the same Reader's Digest version of our own beliefs, because they're not allowed to read all of it. We keep that stuff sacred. And at the same time, they will accuse people who look at the stars and clearly explain it to you of hiding something, because it's witchcraft. Because knowing when to harvest and when to plant, that's cheating. It's God's will. You're not supposed to be able to figure out favorable times to plant and harvest by using a fixed position observatory like Stonehenge and maybe have more reliable food sources. That's an unfair tactical advantage. We have to murder you. But anyway, I'll divert away from that. So over this hard-won period of time, through navigating at sea, on land, trying to figure out when it's good to harvest, trying to understand the universe, and in some cases, because of the belief systems that were being pushed by the same group of people that would kill you for talking too much, wanting to know when it was a favorable star sign to be born under or something, you end up studying the stars very, very well, and the planets, and determine you can easily check if you just put observatories very far apart and also pretty much next to each other sometimes, and or doing observations 6 months apart, that the stars are not one distance, that the planets move, that there are specific distances, and the distances change. And even when you map this, no matter how you map it, they can't all orbit the Earth. The only thing that seems to match cleanly with that is the moon. And even it seems to get smaller and bigger and wobble a bit. It's not perfect either, which means its orbit around the Earth is not completely circular. The Earth going around the sun also shows the same characteristics. Even through a fogged chunk of wine bottle glass, you can tell that the sun has defects in it, dots and spots, pocks upon the sun. You also determined that our orbit around the sun, which is what it is, isn't perfectly circular. The Earth isn't perfectly circular because you can go 1 mile over and get a slightly different number for the angles because there's a local gravitational anomaly, or just the fact that you're on a mountain versus a valley can affect these things, and you have to accommodate for them. When you're at sea, low or high tide can affect your angles. So you find out by doing all of these things that the world and its place in the universe isn't what you're told to believe over and over again by groups of people that may or may not decide the Earth is round or flat for sake of argument, or whether it should be ruled by, us voting versus you having to put up with some snot-nosed kid who's destined to be your leader no matter how qualified he is, because God said so. I promised I wasn't going to go off on that. So all this hard-won information that really does take, at minimum, 2 or 3 years, if you're lucky, if you get a lot of clear skies, or if you can just go above the cloud layer on the top of a mountain and do this every winter, or just one giant long winter and get really lucky and really practice it, you can learn all of this in 1, 2, 4, or more years and get good enough that you understand intellectually why we use a sextant to navigate the Earth, or why these angles are more important than your preconceived notions and your lack of interest in learning something that inarguably takes almost a college-level education, or at least some dedicated time to do. But then again, sailors had to do it, or they'd die because they went to the wrong location, and people trekking across the trackless desert would die from going the wrong direction too. Ignoring reality because it's too much work isn't a good excuse. Thanks for watching. Have a good day. Good luck with that.